All right, we're back. This is going to be part 3 of chapter 3 of the Managing Information Systems Databases. Looking at the data-driven websites. Now, data-driven websites, people use these all the time. And they can be, some managing information systems have a web component that they provide to their customers or their employees to access certain types of data. So we do that here at Douglas College, and what I can do is I can show you an example of how that would work. If you want, you can open up the Douglas College web page and go into where it says current students, and down here to where it says course scheduling tool. Now, all of our courses are in a database, part of our managing information system here at Douglas. So if you go into course scheduling tool right here, it tells you a little bit about what the tool will do, and this is the interface right there. Now, it's part of what they call the banner system that's developed by this company here, and they've used a company called Oracle, the Oracle database. They've written all this in SQL and other scripting languages, probably JavaScript and other languages, to be able to interact with the system. Now, they give very restricted views. Now, you can see here that at the time of this recording, I can go in here and I can look at the fall 2020 courses, but I can't look at anything else. They can control exactly what the users want. So when I click on continue, that's the first step. Then from there, more questions. Do I want to look at BC residents, international students? And from there, I can ask another question. I would like to know all the courses that are inside of, let's say, the CSIS program. And I could not be specific to a particular course. I could say the 2200s, for example. I could say all the ones that are off campus, or I could even hold, I believe, the control key down and do multiple selections. And also evening or whatnot, days, instructors, etc. Once I click on search, I've made a request through the web-driven query system of the managing information system to the database to return back the information that I want. So it's processed it and it's returning back the information, and here it is right here. So that's exactly the information I want, and I can see all the instructors that are teaching this course, their times, any information that's pertinent that they provide to me as a user. This is the same information faculty use as students use. So we can go in here, we can click on a bunch of these to build a schedule, but at the time of this recording, all the schedules were done online, so the worksheet produces no real schedule. There is a schedule because some of the instructors do it synchronously online. I do an asynchronous course. As you guys know, you can watch my videos anytime you want, as long as you come back and do the assessment during the Friday block. All right, so there's an example of how the data-driven website works with a managing information system. Practical example. So you can improve access to information. You can provide information as needed, when needed, to your users, to your customers. And it helps reduce, the overall maintenance and that you would normally have to do if you were to do this in a static site. So it makes your system more dynamic, which gives you a competitive edge. Can you imagine if we didn't have that tool? Some people might think, well, let's go to another institution where they've got it. Of course, it's giving the current information. As soon as you query it, that's live data. That's the most up-to-date information because you're accessing the database right there and then. All right, let's look at the distributed databases. Now, distributed just means that it's distributed, meaning in multiple locations, but it's still a database management system. So it stores data in multiple servers throughout an organization or cloud. Now, depending on the structure and the type of data and where it lives, they may do this for a couple of reasons. For speed, because it's being accessed all the time. You've got people accessing it at one geographic location compared to another. So it might be for speed. It could be for redundancy, to keep the data intact in case there's a server that goes down, there's a fire, there's a water damage. You've got the data in redundant distributed locations. So there's several advantages for this, but again, it could be quite expensive to have this because you're duplicating everything. And it's designed better to reflect the firm's structure. So sometimes data can be also designed around how companies have evolved and have expanded and organized. I'm sure that Amazon would have had a distributed database management system. You could imagine how Amazon works. All the customers, which is virtually hundreds of millions of people, with distribution centers all over the country, if not the world. And they very carefully organize how their data structures work. In fact, Amazon in Vancouver is opening up, I think it's close to 3,000 new jobs, and this is an area that's going to be needed to be filled. So if you're looking at a career choice, you want to work for Amazon and make good money, this is a good choice right here. Local data storage reduces response time. Well, with the internet nowadays, that definitely has been reduced, but it does add its advantages, especially with an educational institution, like I mentioned in an earlier video, that your data for students must be locally stored. And there's some cost advantages to that as well. Now to do this, there's a few different points here. This fragmentation, where basically fragmentation is where the tables are divided and put in different locations logically to best accommodate users, speed, etc. And this is a whole strategy, but fragmenting distributed database systems is part of it. Replicating, again, this is to make copies of it, and they basically have a mirror image, and they put these in different geographical locations. If there's ever, let's say, a fire or a catastrophe, you've got a duplicate copy stored in a different location. Google is very famous for doing this. That's how their search engines are so fast. They replicate their search engine results globally, so you can access it to the closest node to you when you're doing searches. And allocation, meaning that certain people have allocation to certain data at certain places. So it's a process of requesting access to a data set. For example, students only have certain access, as the example I just showed you here earlier with this one here. You guys have access to this data, but limited amount of access. So it's within the distributed database. You have to be very careful about who gets access to what databases if it's being distributed over geographical location. All right, let's move on to the data warehousing. So it's exactly what it sounds like. Data warehousing, you take historical data or data that's not necessarily going to be used readily. You can warehouse that data. And this is a common practice of archiving. Sometimes you might have heard of the term archiving. So it's a collection of data from a variety of different sources and storing that data. This data can also help support decision makers and different applications such as KPI, which is the known performance indicators. And these are questions that you can ask of historical data to help show what the projections are for the future. We have a course that talks a lot about this. It generates business, and it's focusing on business intelligence. It's the CSIS 3190 course, and what they do in that course is they look at historical data and current data, and they do projections. They look at this data and start asking questions. It's you might have heard the term trending. Sometimes if you see a stock market chart, you'll see the historical archived warehouse data and then the current data, and people use that data for making predictions of maybe of when to buy and sell. So you can imagine how important that data would be for making decisions. So it's a known performance indicator, which is a whole area of study, and being able to ask these questions, which is really it comes with experience and being able to think about what do you really want to get out of the data. So understanding your data to be able to ask those questions to get those performance indicators out of it. You can get with historical data, and when you warehouse data, you can collect all that, and you can start answering questions by looking at their known performance indicators. Companies use this for projecting into the future. They forecast how many employees are they going to need based on what's happened in sales in the past. What are they going to need in the future? They may have to hire people. If they don't do this, then they could be stuck with an over number of customers and not enough service to supply it. They're going to lose out on opportunity. So it all fits it's all part of that puzzle that puts it together to paint the picture so you can get a clear KPI. So there's different characteristics of the data that can be kind of looked at individually, like segregating certain subjects, the data by subjects. So you can group it together, different data. It comes with a variety of different sources. There could be data coming in from different areas. You could bring in people from sales, from your salespeople, to your human relations, to the accounting. They could be coming in from different areas. Of course, grouping it by time is a big factor for forecasting, as I've said. Accumulating the data, aggregating your data, again, to find out during certain quarters, like the first, second, third, and fourth quarter, you can aggregate your data to come up and see how a company has been performing. And of course, analyzing for analytics is so important with warehouse data. So you've got all this data that you can look at in a variety of different ways. These are different kind of characteristics of how the data can be grouped. All right, now in this slide here, kind of bringing it all together in this data warehousing. So this symbol right here, this can shape, is think of this as a database. And you can have databases coming in from external sources. You have data coming in from GIS systems, graphical information systems. You can have your own internal database systems, or you can have individual sales transaction data, and so on. There's other different database systems that you can pool together or bring together from these different warehouses into some kind of database management system right here to help extract what you're looking for, transform that data, and load it in, I guess that's what they're saying. From there, you can create a new data set that you've created from a variety of these different warehouse data. And this would be an online analytics analysis that could be done. From there, you can also do data mining analysis, which is another type of, you've probably heard of that term of data mining. Data mining is by collecting all these different sources, pulling things together, and coming up with some kind of an analysis that you're looking for, some kind of answer, some kind of deep-rooted answer by pulling all this data to try to correlate the data to find some meaning in it. And why do we do this? To help us make decisions and to put this together in a meaningful, coherent way so that we can give it to management to say, here's what we came up with. And it's up to them now to whether they want to make the decision to pursue it or not. So staying on that data warehousing idea, we have to really go back and consider that input. So each of these little black arrows is really bringing input into that database. So in the input, you're looking at different data sources, as in the previous slide. Provide the input, or does provide the input from all those external data warehouses to help you perform the analysis, to help you generate the report. So that's kind of summarizing, I guess, this entire slide here. All these external data sources going through the database management system to pull it together to get down to that report right here. Now, you can get there through external data sources, as I've just alluded to, and your own transactional files. You can also access things called the Enterprise Resource Planning, or ERP. And we'll actually spend a little bit of time talking more about ERP systems, because a lot of companies out there, their management information systems are embedded within these larger enterprise resource planning. It's part of a bigger picture. A lot of companies have these integrated modules, and that's what ERP systems are used. And all of those different systems can be all warehoused, and they can all bring in different inputs to help answer some questions that you're trying to do. Another area within an enterprise system could be your customer relationship management system. This is another kind of managing information system specific to customer relationships. So if you're in a marketing program, you would probably want to focus your energy on customer relationship management, since if you're in marketing, the focus of your job is going to be working with customers and managing customers and how they integrate with other parts of the systems within other organizations. If you're working for a large company like Amazon, Amazon has a massive CRM, customer relationship management, to keep track of all the people, all the customers, and it works very closely with the enterprise resource planning system, because that has to do with the the shipping and the purchase orders and the marketing and all these other different areas. And the CRM is part of that ERP system. So to wrap up this data warehousing, and this is really an introduction to it because we're going to be spending a lot of time as we progress kind of expanding on this concept. So hopefully in this chapter, you guys get a rough idea of what we're talking about here. And then as we progress through the next chapters, we'll keep elaborating on that. So we've got something here called the ETL, this extraction of the data. We want to transform the data, and then we want to load the data so that we can use it. And this all happens through the processes used in data warehousing. So we do that by collecting data from a variety of sources, as I've just alluded to, and converting data into formats that can be used and transformed, or it's in the transformation process. As again, I think I've explained already here. Loading data into the data warehouse is the back end, so we can actually use that and do our analytics on it. So why do we do all this? What's the purpose again? Well, we want to come up with meaningful information. And the end goal of all of this is really, and this sums it up really nicely, is to have your data tell a story. And it sounds kind of quirky or kind of silly, but when you look at data and you see it over time, and you've warehoused all this data, you've analyzed this data, you can start to see a story emerging from it. It's hard to give you an example here, an anecdotal example, except maybe stock data. I mean, I use this a lot because stock data happens over time. And you can simply look at a single data point like price, and price over time fluctuates up and down. Stocks will show you a trend, and that trend will tell a story, and that story could be that the stock is plummeting. Now, there's a lot more components to that, but that's kind of an example of what they're trying to get across here. But you have to extract that data, transform it, then load it so that you can tell a story about the data. Now, there's another component here called storage, and storage is really the storage, of course, of data. It's the collecting information, organizing the data in a warehouse, and you can do that in a few different ways. You can store it as raw data, sequential. You can store it as summative type of data, where you're just grabbing, not the individual data, because that might not be as important as like you want to know what the total was for the day. So sometimes people, when they have like a cash out at the end of the day, they don't want to look at the individual records. All they want to know is what is the summative data, the aggregate data of that day. That would be an example of a subtotal. Then there's something called metadata. Now, metadata is sort of the data about data. It's smaller individual components of data. Meta, just a smaller amount of the data that you can extract. These are finer detail aspects of the data. All right, now the last kind of area of this whole MIS model is the output, the information it generates, the reports. They're all interused. You can use those terms interchangeably. When they talk about output, you're talking about the report. You're talking about the information it generates. So when you're dealing with data warehousing, it can generate different types of reports. And as the earlier graphic showed here, you can generate what they call that online analytical processing, OLAP, which is it's a very specialized way of looking at the data to analyze this online data. And again, it uses multiple sources from a variety of different external, internal sources. It's a multi-dimensional analysis. These are a very complicated type of analysis on the data. You can also use this to generate business intelligence, which I would consider OLAP a form of business intelligence. Again, because you're using multiple sources, bringing them together to ask these more complicated questions and tell a story about your data. Data mining is another term that you hear because you're going out into multiple external and internal sources, grabbing data that you need and analyzing it. And this data mining analysis is really a complicated one. I've been involved with a little bit of this, and it's very intriguing. But it's a process of discovering patterns and this is really interesting, patterns in these large data sets from a variety of different areas, and looking and trying to find the bigger picture. And this, where data mining is really going to become significant, is when quantum computing becomes more readily available. So when quantum computing comes out and they can do massive processing very rapidly, they can put in these massive data sets and do this called discovering patterns. So that they can put the question to the computer that says, look for patterns in these massive data sets and see what those patterns are, and look for trends in the patterns. So I think most of you are going to see, this quantum computing coming up in the next 5 years, where it's commercially available to companies to be data mining their data with other data sets out there to look for these patterns. Very exciting time with databases right now. And again, uses the discover patterns and also look for relationships. So it's not just patterns it's looking for, it's also relationships that's also in there. So why are we doing it? Why are we going through all that? Well, the reason we're doing it is so that we can assist our managers, the owners, to make really good decisions based on concrete data analysis, so they can make projections. So you could imagine some company like Amazon, when they're looking at expanding their market and putting in a distribution center in a geographical location, they would be bringing data sets in from geographical locations, from civic data sets, demographic data sets, bringing all of this together to do a full OLAP type of business intelligence analysis before they actually build a distribution center in a geographical location. Like in Vancouver, they built one in Delta, and they put their office in downtown Vancouver. There would have been an incredible amount of well thought out data analysis to make that decision. And you got to think of the millions of dollars, if not billions of dollars, that this can generate for a company. And it all comes down to looking at how the data works and what the best decision to make for that. So that's what the output, that the ultimate goal is to get that information so that management can make those high demand type of information decisions to make their companies profitable. Data marts is, you don't hear about this a lot. The book talks about data marts as sort of a smaller version of data warehousing concepts. It's used more it's just a smaller type of a scope, I guess. It's a single department or function rather than having brought in from multiple different areas. It has advantages over the data warehousing. It's not as big. As a result, it can be faster to access the information. It improves response time, etc. So you guys can go through and read a little bit more on data marts. Of course, it would be less expensive. It's not. And there's a little graph here to explain kind of how a data mart works. Again, it's more of a hierarchical type of structure where the data warehouse is broken down into smaller data marts. So what I was talking about earlier here was the bigger picture of the data warehouse. A data mart is a subset of a data warehouse. So people put together already packages to access this and make it a little bit easier. So there is some advantages. Again, the downside would be you don't have access to the full data warehouse. You have limited access, of course. So a data mart would be a subset of the data warehouse. All right, so I'm running out of time here, so I think I'll cut it off here and we'll do another video.